Okay, I think I left off and I was talking about the alternative hypothesis, so let me just get back to that. And that was that our alternative hypothesis is going to be about the same population parameter as the null hypothesis. Okay, let me just check to see if this is recording, and it is! Yay! Woohoo! Okay, it's going to be about the mean height of women who have smoked, but it's going to be stated in much general terms. And since our hypothesis is about does smoking stunt growth, does it make them less than average, then we're going to use the less than sign. Okay, so this is sometimes called a directional hypothesis. Okay, and the reason it's directional is because it specifies sort of where on the continuum, because when we say that mu is equal to 63.85, it could be that mu is much greater than that. It could be mu is much less than that. Both of those are possibilities when we say is it different than. Here we're saying it's less than. We don't care about the greater than, we care about the less than. Okay, so that's our null and alternative hypothesis. Okay, our next step is we're going to choose a sampling distribution. Sampling distribution. Okay, now if you forgot what a sampling distribution is, you should go back and review what a sampling distribution is. All right. What do we know about this? Well, we know that we're interested, our null hypothesis is about one mean. We know that. We know that the central limit theorem is coming into play. We know, what do we know about the sampling distribution of the sample mean? Well, if you recall, the mean of the sampling distribution of the mean is equal to the population mean, and the standard deviation of the sampling distribution of the sample mean will equal the standard deviation of the population divided by n. And we know that the central limit theorem will hold. That means that the distribution will be normal. Okay, so we can use the standard unit normal distribution to help us here. And we know that a z unit normal will equal we know that if we take the mean minus the population mean of the sampling distribution divided by the standard error of the mean, we will get a z, and that z is normally distributed, and we can then use that as our sampling distribution. And because we know these particular facts, we know all the values here. So our sampling distribution is going to be a normal distribution, where we're going to be using a z unit normal, and this is called a z-test. Then we're going to use the z distribution to compute our value. Okay, and do our hypothesis testing. Okay, on to step 4. Step 4 is to set a significance level. And there's a second part of this that I don't talk a whole lot about, but I'm going to note it here, and that is, and we only really need to go over this once or twice, and then you're going to learn that it's always the same. And we're going to state a decision rule. Okay. Now, what is the significance level? Well, significance is given in a statistical test by the letter alpha, the little Greek letter alpha. Okay, and it's sort of like our confidence level. It's how sure we want to be in ourselves in doing this sort of work. It's our significance level. In psychology, we generally set our significance level to 0.05, and what that means is that we know that we can't be completely sure of ourselves, because we're going to be selecting samples, and sometimes you get wildly extravagant values, and even in a distribution. But what we're saying is that in general, we're going to have a 1 in 20 chance of not getting it right, so to speak. Okay, let me try to explain, and that is that we have a mean, and the sampling distribution of those sample means is normally distributed. Okay? And these are all means, and we know through the three amazing facts that this is a normal distribution. And what we're saying is that if our mean comes down in a region over here, if our sample mean comes down in a region over here of 0.05, we're going to conclude that our mean didn't come from this distribution. This is the distribution of means of size 64 of all women. That's what this distribution is. Now our sample is a sample mean from with a sample size of 64, but it's women who've smoked. And if our mean comes down in this region, what we call the rejection region, right? This is our critical value. If it comes down over there, then we think that our mean really isn't part of this bigger distribution, but maybe part of another distribution of women who, this is women who have smoked, and then this, or not smoked, and then this is women who have smoked. We think that smoking, if smoking produces a change in women's statures, it's going to shift the whole distribution down. Okay? So, what does that mean? If I'm going to draw this distribution back over here, if we're looking at a 0.05 over here, what that is what we call our p-value. And if our decision rule is going to be if our p is less than 0.05, our alpha level, then we reject the null hypothesis. A p-value is the probability of our results under the condition that the null is true. And if that p-value is less than 0.05, one of these two things is wrong. Well, our results are good. We know we're good scientists. We did a good experiment. We believe in our results. What we wind up doing is rejecting the null if our p-value is less than 0.05. Okay. I don't know if that makes any sense. Hopefully it does. We're going to be encountering this over and over again. 5, we're going to compute our statistic. Okay? Our z is equal to our mean minus the mean of the sampling distribution divided by the standard error of the mean. So that's going to be equal to 62.4 minus 63.85 divided by 3.82 divided by the square root of 64. That's the standard error of the mean. We got the standard deviation, but remember the standard error of the mean is equal to the standard deviation of the population divided by the square root of n. The mean of the sampling distribution of the sample mean is equal to mu. Those are our two of the amazing facts. So if we go and do this math a little bit, we're going to get negative 1.45 divided by 0.4775. That's equal to negative 3.03. Now, this is a z. It's a z unit normal. So I can use table A, or I can use norm s dist, and I can look up that, and I find the p associated with a z of negative 0.303 is 0.0014. That means that if the null hypothesis, if we assume the null hypothesis were true, the probability of getting a sample of 64 with a mean height of 62.4 is 0.000014. If this is our scale of p-values from 1 to 0, our p-value is down over here. It's down over here. If this is our probability scale of sure thing to not going to happen, ours is way down there. The probability that our sample came from a distribution described by these features right here is really super low. So, what we do is in step 6, we state that, our conclusion. Since our p is less than 0.05, we reject the null and accept the alternative. And we have evidence to conclude that